Hey guys, I welcome you all to this live session by Great Learning. So the topic for today is Python for data science. Python and data science are in really high demand, and that is why Python programmers as well as data scientists get paid really huge salaries. So keeping that in mind, we've got this live session for today. Now, without much delay, let's have a quick glance at the agenda. So we'll start off by installing Python and we'll also install some IDEs. So we'll install PyCharm and we'll also install Anaconda and we'll work with these and understand what exactly are these. After that, we'll look at some basics of Python. Now, when I say basics of Python, we'll basically work with data types, variables, and operators and properly comprehend what are these. Going ahead, we'll work with the data structures in Python. So the basic data structures in Python would be tuples, list, set, and dictionary. So we'll work with each of them and have some practical demos with all of them. Now, once we're finally done with all of the Python concepts, that is when we'll go ahead with the data science concepts. So we'll have a firm introduction to data science, and then we'll look at the data science life cycle. So what are the different steps involved in a data science life cycle? That we'll properly understand. And then finally, we'll have a simple introduction to machine learning and how does it exactly fit into the world of data science. All right. So let's start off. So what exactly is Python? So simply put, it's a free and open source language. Now, when I say it's a free and open source language, just plug and play. All you have to do is download Python and then you can start working with it. It is as simple as that. And also you can modify the code and add your own innovations to it. That is what makes Python so great. Python is also cross-platform compatible. Now, what do I mean by this when I say Python is cross-platform compatible? It basically means that you can run Python on any operating system. So if you're working on a Windows system, it's totally fine. If you also have a Linux or a Mac, it's totally fine. So let's say if you write a piece of code on a Windows system, you don't have to worry at all. You can take the same piece of code and if you try to run it on a Mac, it'll easily, smoothly work. Now, Python is also object oriented. I have a question for you guys over here. So guys, tell me what is, so when you see around you, what do you exactly see? You see a lot of objects, don't you? Now, if you have, let's say, a water bottle with you, what exactly is a water bottle? It's an object, isn't it? Now, if you see a phone, what exactly is a phone? It's an object again. Now, let's take some real life objects. If you see a dog, what is a dog? It's a living object, isn't it? So we are surrounded with all of these objects. And programming basically involves implementing or working with these real life objects in the programming paradigm. And that is what is known as object-oriented programming. And Python helps us to seamlessly integrate all of these real-world objects into the programming world. Python also has a very large library. So let's say if you want to do data manipulation, Python provides a package for that. If you want to do data visualization, Python provides a package for that. If you want to do numerical computation, Python also provides a package for that. So whatever your requirement is, Python will spring up a library from its head. And considering all of these is what makes Python such a great language. So now that we have a quick introduction to Python, let's go ahead and see how can we actually install Python. So we can install Python from this particular site over here. So we'll go to python.org downloads. So let me just click on this. So let's just wait till the site opens up. Right, so this is the latest version of Python, Python 3.8.2. Now, since I have a Windows system, I'll download it for Windows. And similarly, if you have a Linux or a Mac system, then you can download it for Linux or Mac. Now, I'll just click on this and the download would start. Right, so we're done with the download of Python. So this is how we can install Python. Now, we would also need an IDE. So what is an IDE? An IDE basically stands for Integrated Development Environment. So for some of you who already have worked with a previous programming language, so let's say if you have worked with Java, then you would know that for Java, you can use an IDE called Eclipse. So what does Eclipse provide you? It basically provides you a set of tools. It provides you prompts so that your programming is done in a much more smoother way. That is why we would need IDEs. So similarly for Python, we have a lot of different IDEs, and the most commonly used IDEs are PyCharm and Anaconda. So first we'll go ahead and see how to install PyCharm. So to install PyCharm, you'd have to go to this particular site. So you'd have to go to jetbrains.com. So I'll click on this. So let's just wait till this opens up. So you have the download button over here. I'll click on download, and we have the professional version as well as the community version. And since we just want it for simple Python development, I'll download the community version. So I'll click on download, right? And the download would start over here, right? Now I'll actually go ahead and cancel this because I already have PyCharm installed on my system. And since all of us are actually in a lockdown, I really don't want to waste my Wi-Fi. So I'll just go ahead and cancel this. So yeah, so that's how you install PyCharm. Now we'll go ahead and understand what is Anaconda. Now Anaconda, when compared to other IDEs, is very, very popular. So why is that? That is because Anaconda is actually a distribution, and it's not just for Python. It is a complete distribution for both Python as well as R. Now, what do I mean by distribution? So it is not that it just provides you some sort of tools. What it does is it will give you a lot of different things. So here I've went to the site, I've clicked on download, and as you see over here, it is basically a distribution which would provide 7,500 plus packages with respect to Python and R. So you have packages such as h2o.ai, you have NumPy, Pandas, you have Bokeh, right? So with respect to R as well as Python, you have numerous packages. So whatever your requirement is, Anaconda will definitely provide a particular tool for you. And the best part about why most people use Anaconda is the Jupyter notebook. Jupyter notebook is the most widely used interpreter, or basically the IDE for Python nowadays, right? So now let's see how can we download this. So again, since I'm using a Windows system, I'll download this for Windows. So we've got Windows, Mac, and Linux over here. So if I'm using a Windows system, just click on Windows over here. And this is the latest version of Anaconda, which is Python 3.7. So click on download again, and the download would start. So this is how you can install Python as well as Anaconda. All right. Now, again, since there's 466 MB, I'll just hit cancel over here. Well, I'm very stingy when it comes to using my Wi-Fi. Right. Now, once we are done with this, we will have something known as a Jupyter notebook, which comes pre-installed in Anaconda. So as it is stated over here, Jupyter notebook is a browser-based interpreter that allows us to interactively work with Python. Now, what is a browser-based interpreter? Well, it is basically in the name. It opens up in a browser, which makes your work very easy. And also it's an interpreter, so it basically executes your code line by line. So it is a browser-based interpreter. Now, let's see how can you work with Jupyter Notebook. Now for that, after you installed Anaconda, you would basically have two options. So let me just type Anaconda over here. Now, when you install Anaconda, you would have something known as Anaconda prompt and also Anaconda navigator. So Anaconda prompt is the command line interface where you type in commands, and Anaconda navigator is the graphical user interface where you basically have the option to choose and select your options. I'll show you both of them. First, let me go ahead and open Anaconda navigator. So it'll take a bit of time to open up, so let's just wait till it opens up. So till then, I'll also show you how to work with Anaconda prompt as well. So this is what you see. So over here, you have Anaconda prompt. You click on this. So this is the base environment. So you have a lot of different environments over here, and this is the base environment. And in this base environment, if you just have to open Jupyter Notebook, all you have to do is type in Jupyter. Now here you'd have to remember that Jupyter is actually, so over here it's Y and it's not I. So you type in Jupyter, and after that let me just minimize this for a bit. After this, you type in notebook, and when you hit enter, it'll open up. Right. Now, okay, so there seems like some error at the navigator. Okay, well, leave it out for now. So what we'll do is, well, I actually have my notebook opened over here. So I will just open up a new prompt over here. Let me close my older tabs from over here. Let me show you how it's done. So I'll type in Anaconda prompt. Let me just type in Jupyter notebook. Now let's just wait till this opens up. Right. So we have successfully opened up this. So this is how your Jupyter notebook will look like. Now over here, if you see, you have the new option over here. So this is how you can create a new notebook. So I'll click on this and I would want a new Python 3 notebook. And I have opened a new Python 3 notebook over here. Right. You have all of these different tabs over here. So you got file, edit, view, and insert. Right. So this is our new tab. So I'll just name this to be, let's say, Python for data science. I'll rename this. Seems like we already have a file with the same name. So I'll just add a suffix called final over here and I'll rename this. Right. This is done. So once you have written all of your code and if you want to download your notebook, so you would have to go to file and you have the option of download as. So you have all of these options over here. So you can download your file with all of these different extensions. So in general, whenever we are working with a Jupyter notebook, we download it as a .ipynb file. So this, what you see over here, this is a .ipynb file and this is a notebook, right? Now it's the time which you've been waiting for. We'll go ahead and write our first Python command. We'll just write something simple. Let me just put in print over here. So you put in print, you will put in the braces over there. And then inside that you put in quotes. Now I'll type in this is Sparta and you click on run. Either you can click on run or you can just hit Control Enter. So I'll click on run and you have successfully run your first Python code. Well, guys, you've written your first Python code and you are on your way to hacking NASA. Well, baby steps right now. So just know how to work with Python. And these are the basics of the Jupyter notebook. Now let's also go ahead and look at other tabs over here. Now let's say if you want to insert a cell above this or a cell above this. So this, what you see is actually known as a cell and you run all of your commands inside a cell. Now if I want to insert a cell below this, I'll just do it here, right? If I want to cut a cell, I can cut a cell like this. Now, what is a kernel? Kernel is basically that engine which runs or executes your code. So you can go ahead and interrupt your kernel, restart your kernel, or even shut down your kernel, right? So guys, these are the basics of Jupyter Notebook. Now let's go back to our presentation. Let me go back to this. So we have installed Anaconda. We've also installed Jupyter Notebook. Now let's go ahead and start with some basic concepts in Python. So now when it's any programming language, the first question would be, how do you actually deal with data? So again, programming is all about data, isn't it? You're working with data. So where do you store that data? That is the primary question. Now, let's take a simple example. So let's say you have 3 students whose names are John, Sam, and Matt, and you'd want to store the names of these 3 students somewhere. So how do you do that? So this is where a variable would come in. So as it is stated over here, a variable is a temporary storage space in which you can store values. So what you do is, let's say if you want to store the name John inside a variable, you will take this and store inside this. So over here, we have a variable with the name student. Now you have to keep in mind that a variable will have an address associated with it. So as you see, this is the variable with the name student, and this is the address associated with the variable. And I am storing this value in this variable, which is present at this particular address. Now, this might seem a bit complicated, but when we work with the examples, it will become very simple. All right. So as I've already told you, it is a temporary storage space. So you can keep changing the values again and again. So initially initially we had the student variable in which we had stored the value John. Now, after some time, let's say I don't really like the name John a lot. So I just take this name, I'll throw it away, and then I'll take Sam and store Sam in student instead of John. Again, since I'm very fickle-minded, I'll throw Sam away and I'll store Matt inside student. So this is how variables work. So you can keep on storing different values in one particular variable. Now let's go ahead and work with some examples of this. So let's say I create a variable with the name student, and inside this, I will store the value John. I'll click on run. Now let me just print this out. So as you see, this variable student has the value John. Now I'll go ahead and change the value. I'll change John and I'll make it to be, let's say, Matt. And I'll print out student over here. Now, after some time, let's say instead of Matt, maybe I'll just put in Tiger Shroff over here because he was the student of the year after all. So I'll click on run and then I'll print student, right? So we have student over here. So this is how variables work. So you can take a variable and then you can keep on changing the values which are present inside a variable, right? Now, after variables, there is a simple concept called as data types. So every variable is associated with a data type. Now, a data, basically whatever data you see. Now, let's say if you work with numbers just 10 or 500, these are called as integers. So basically numbers without a decimal point are called as integers. And when you work with numbers with decimal points, they're known as floating numbers in Python. Then you have Boolean type. So in Boolean type, you would have true and false. It's basically 0 or 1, right? You either have two values, that's it. It's either true or false. You don't have any other value over there. And when it's string, you have a sequence of characters. Sam, Matt, I love pizza. So all of these are strings. So now let's go ahead and assign different data types to a particular variable. Now what I'll do is I'll create a variable with the name var1, and first I'll store a floating point value because we've been storing strings. So now I'll store a floating point value. So this is the name of the variable var1 and I'm storing 3.14 inside this. Let me check the type of this. So the type of this would be float. Now inside var1 I'll store 300, which is an integer. Now let me check the type of this, type of var1. So we see that initially when we had stored 3.14 into var1, its data type was float. Now when we stored 300 into var1, its data type is int. So basically the data type of a variable would depend on the type of value which we store into the variable. So now let me go ahead and store a Boolean value. So I'll type in true over here. Now var1 and let me check the type of this. So type of var1, and as you guys can see, this is of Boolean type, right? So this is how we can work with different data types or assign different data types to a variable, right? Now another simple concept is operators. So we've got relational operators, arithmetic operators, and logical operators. So let's work with all three of them. So let me add a comment. Now, what exactly is a comment? So comment is something which is not executed in Python. So I'll put in a hash over there and I will type operators. And when I click on run, you see that nothing has actually happened. So when I remove the hash over there and then when I click on run, you see that name operators is not defined. This is because if you don't put in a hash over here, then Python interpreter will consider this to be a variable which is not yet defined, and that is why we have the error over here. But we just want this to be as a comment. Now we, as a programmer, you generally add comments because that adds into the readability of the code. Or let's say you are writing a very complex level code which can be understood by only a set group of people. So what you do is you explain each step properly so that anyone who reads the code can understand what is happening in the below lines. Right. So now let me run this, and in operators, we'll actually start with arithmetic operators. So in arithmetic operators, we would basically have plus, minus, we would have division, and then we would have the multiplication operator. So these are the basic arithmetic operators. Now I'll store 10 inside A and 20 inside B. So these are my two variables. Now I'll perform some basic arithmetic operations on them. Let me do A plus B, right? So A plus B is 30 because 10 is stored in A and 20 is stored in B. Now let me do A minus B. We get minus 10 because 10 minus 20 is minus 10. Then let me do A star B. So A star B would be 10 into 20, which basically becomes 200. And then let me do A divided by B, which basically is 10 divided by 20, and that becomes 0.5, right? So these are the basic arithmetic operators. Now we'll work with relational operators. So I'll add in another comment over here, and I'll put it as relational operators. Now the different types of relational operators would be less than, then we've got greater than, then we've got the double equal to operator. Let me just put in double equal to over here. And then after this, we've got the not equal to operator. So again, we'll take the same A and B. Let me just print out the values of A and B for you guys over here. So 10 is stored in A and 20 is stored in B. Now, what I want to do is I want to know the relation between these two. So I want to see if A is less than B. So A less than operator B, and I get a true value because 10 is less than 20. Now similarly, if I put in A is greater than B, I get a false value because 10 is not greater than B. Now if I put in double equal to, which will check if A and B are actually equal. And over here, I again get a false value because 10 and 20 are not equal. Finally, I'll put in A exclamation mark equal to B. So when I do this, I get a true value because 10 and 20 are not equal. So these are the basic operators in Python. So we are done with this. Now let's understand what are tokens in Python. So as it is stated over here, these are the smallest meaningful components which basically make up the entire code. So operators are one of the tokens, and we've already worked with these operators. Now let's work with other tokens. So we've got keywords, identifiers, and literals. So let's start with keywords. So keywords are basically special reserved words in Python or in any programming language, and you can't really use these keywords for the names of a variable or a function or an object. So these are the different keywords you have. So let's say false, true, def, continue, and so on. Now, let me show you an example of these Python keywords. So let me go ahead and cut all of these. So there's a lot of code over here. Yep. So I've cut all of these. Now, let's say if I type in true. So as you see, this has turned green because the Python interpreter understands that this is a keyword. Similarly, when I type in def, Python interpreter understands that this is a keyword. Now, let me put in, let's say, class again. Python interpreter understands that this is a keyword. So these are special reserved words in Python. Now we'll understand what are identifiers. So identifiers are basically the names which are given to the variables, functions, or objects. So now let's say we had created different variables. We had created a variable with the name var1 student. So all of those are the identifiers of the value. Now These are some rules when it comes to the Python identifiers. So you can't really have any special characters in the names of all of these except underscore. So except underscore, you can't have any other special characters. And also these are case sensitive. Now, what do I mean case sensitive? Again, I'll show an example to you guys. Let's say if I create a variable with the name student over here and I store John, and I create another variable student where S is capital, and inside this I store James. Now both of this would actually be different. So let me put in student, and after this let me put in student with a capital S. So as you see, both of these are different variables which have different values stored in them. Also, I mean, it's a simple rule that a variable or any of these identifiers cannot have the first letter to be a digit. So there are some simple rules to be followed when you are working with these identifiers. Now, the final token is the literal. So literals are basically the opposite of a variable. Variables keep changing, a literal doesn't change. A literal, as the name stands, it is basically constant whose value is fixed. So the values which you store in a variable, let's say 10, 100, 1000, all of these values, right? So 10, the value 10 always remains 10. It doesn't really change. That is what is known as a literal, right? So all of these were the basics. Now let's work with Python strings. So let's understand what exactly are Python strings. So Python strings, as I've already told you, these are a sequence of characters either enclosed within single quotes, double quotes, or triple quotes. So over here, we've got a string enclosed in simple quotes, then we have a string in double quotes, then we have a multi-line string over here. So when you use triple quotes, you can have multi-line string inside this. So let's see the example with all of these. I'll just add in another comment over here and I'll add in string. Let me run this. Now, let me go ahead and add some string. So I'll name the first string to be str1 over here. And let's say I'll store hello world. So let me print str1 over here, right? So this is what we have. Now, let me create another string str2, and then I'll create a string with single quotes. Over here, I've created a string with double quotes. Now let me go ahead and create a string with single quotes. And inside this, I'll type in Sparta. So let me just type in Sparta over here. And let me click on run. Let me print str2, right? And let me have str3 as well. And I'll make this a multi-line string. I'll just type this is a multi-line string, right? Now, let me show you what is S3. So as you see, we have this /n over here. So each /n indicates a new line. So first we have this as /n, new line A, new line multi-string, new line string, right? So this is how you can create a multi-line string, right? Now, we're done with half of the concepts. Let me just go ahead and answer a couple of questions over here. So Ari Chandran is asking, do we need both Anaconda and PyCharm? No, Ari. So both of them are different IDEs. Both of them sort of solve the same purpose. So it basically gives you a lot of prompts. It basically gives you a lot of tools. But in general, the Jupyter Notebook or Anaconda is most widely preferred among most of the Python programmers. So you don't need to have PyCharm and Anaconda in your system, but you definitely need to have Python in your system before installing Anaconda, right? So first you install Python because that is the primary software, and then you go ahead and install an IDE. Ravichandran is asking a similar question. which is the best when compared PyCharm or Anaconda? So again, as of now, Anaconda is most widely used, that's most popular. But then again, PyCharm is not really far behind. But in general, it's actually easier to share your work or collaborate when you're working with Jupyter Notebooks and Anaconda. Right. So we'll head back to the session again. Now we've created a string. Now let's see how can we actually extract individual characters from a string. What I'll do is I'll create a new string over here. So I'll type in my string and I will store, let's say let me put this as small, my name is John. Now, if I want to extract the first character out of this entire string, I'd have to give indexing. So in Python, you'd have to remember that the indexing starts with the number 0. So this character over here would have the index 0. This would have index 1, index 2, index 3, and so on. So I'll type in my string, I'll put in square braces, and if I want to extract this particular character over here, I'll put in 0 and I've extracted m. Similarly, if I want to extract the second character, the index for it would be 1. If I want to extract the third character, so even space over here, this counts as a character. So I'll put in 3 over here, right? So this has to be 2 actually. So when I put in 2, I have extracted this. Now, if I want to extract the last character, so if you want to extract the last character, you'll put in -1. So we have seen that we have successfully extracted the last character from this particular string. So these are some basics of a string. Now after this, we'll head on to basics of the data structures. So Python provides us for major data structures, which are tuple, list, dictionary, and a set. Now let's start with tuple. So as stated over here, tuple is an ordered collection of elements enclosed within round braces. Now tuples are also immutable. So what exactly is immutable? So simply put, when you create a tuple, you can't really change the values which are present inside a tuple. So let's say if we have a tuple like this, and if you want to modify this tuple at a later point of time, that wouldn't be possible. And that is why a tuple is known as an immutable data structure. And also it is an ordered collection of elements. So the way you store the elements inside a tuple, the order remains constant. And that is why you can index the elements which are present inside a tuple. So let's work with the tuple now. Let me remove all of this stuff first. So here, let me just put in tuple. All right. Now I'll type in tup1 over here. I'll put in round braces and I'll add a bunch of elements over here. Let's say the first element is 1. After that, I'll put in a character, which would be Sparta, and then I'll give in a Boolean value, which would be true. So I have created a tuple over here. Now, let's head back to the presentation. Once you create a tuple, again, extracting of the elements is similar when compared to a string. All you do is you give the indexing and then you give the values which you'll want to extract. So let's perform the same operation. So if I want to, let's actually add some more values over here. Let's say I'll add 2, hello. I'll also add false over here. So this is tup1. Let me print out tup1 over here. So this is tup1. Now I want to extract the second element over here. So tup1, the second element index would be 1. I'll put in 1 over here. And I have successfully extracted the second element from this. Now, after this is done, let's see how can we extract the final element. So final element, again, all you have to do is put in -1 and we can extract the final element from this. Now, if I want to extract a series of elements, let's say if I want the second, third, and the fourth element from this. So the second element, the index would be 1. So I'll put in 1 over here. So this would be 1, 2, 3. Now you'd be thinking we'll have to put in 3 over here, but that is not right. We'll actually have to put in 4 because the right side index is exclusive. It is not inclusive. So when you put in 3, it will only take Sparta and true. When you put in 4, it will take in Sparta, true, and 2. So when it is 1 to 4, it will take 1, 2, and 3. If you put in 1 to 3, it will take in 1 and 2. So whenever you are giving an indexing like this, you'd have to remember that the outer index or the right side value is it is exclusive, and the first index it is inclusive. So as you see over here, we have extracted Sparta, true, and 2. Right. So these are some basic stuff. Now I will also show you if we can modify a tuple. So we have this tuple over here. Now we've got 0, 1, 2, 3, 4, 5. So this is the element which is present at the index 5. So basically there are 6 elements. Now if I want to add an extra element, the index would be 6. Let me try to add a new element and see what happens over here. Let's say I try to do this and we get tuple object does not support item assignment. And this is happening because tuple is immutable. Once we create a tuple, we can't really modify it. Now let's say if I want to change this value to something else, so the index is 0 over here. So instead of 1, I want the value to be stored as 100. So I'll just put in 100 over here. Right. So again, we get the same thing because tuple is immutable. So this is the basics of tuple. Now, once we're done with tuple, we'll go ahead with the next one, which is a list. So a list, the difference between a list and a tuple is basically lists are mutable, whereas tuples are not. Now, when I say lists are mutable, this would mean that whatever you store in a list, or once you create a list, that can be modified at a later point of time. And also you create a list with square braces instead of round braces. So over here we have an example of a list. So let me just type in list. Let me name the list to be L1. I'll give in square braces and I'll add in a bunch of elements in this again. So 1, A, true. After that, I've got 2 and then B. And then I'll put in false. So I've got 6 elements again in this list. Now let me check the type of this. I'll say type of L1 and you guys see that this is a list. Now let's see how can we extract individual elements. So it's the same thing again, since again a list is an ordered collection of elements, the order is maintained. So if I want the first element, the index would be 0. So L1 square braces, I'll put in 0 over here. And we have extracted this element. If I want the last element, I'll just put in -1 over here. And we have extracted the final element. And if I want the sequence of elements, this would be 0, 1, 2, 3, and 4. So I'll put 2. And this will go till 5 because 5 is exclusive, not inclusive. Right, so I've got true, 2, and B. Right, so this is how you can work with a tuple. Now we'll quickly move ahead with the other two data structures as well, which are dictionary and a set. So a dictionary is unordered. So when compared to a tuple and a list, what differentiates a dictionary from them is it is unordered. So you can't really index your elements which are present over here. And you have a key value pair. So the element which is present inside a dictionary is a key value pair. So over here, this is a dictionary with the name fruit, and you have 2 key value pairs. The first key value pair is apple, 10. Second key value pair is orange, 20. So this is the key, this is the value, and this is the key, this is the value. So let me create this dictionary. I'll type in fruit over here. Let me go ahead and add the first key value pair. Let's say I'll put this to be orange and the value is 10. After this, let's say I like apples a lot and the value is 20. So I have created this dictionary. So let me just print this out. So this is our dictionary over here, fruit. Now, let's see how can we extract the keys and values from a dictionary. So we can't really get individual elements with respect to their index because these are unordered, as I've already told you. But we can actually access the individual keys and the individual values. So over here, the keys are orange and apples. The values are 10, 20. So to access the keys, I'll type fruit, then I'll put the dot operator and I'll type in keys. So this will give me the keys present inside this dictionary. Similarly, if I want to access the values, I'll type in fruit, I'll put in values over here, and this will give me the values which are 10 and 20. So this is how you can create a dictionary and access the keys and values, or maybe even the individual elements from this. Right. So that's a dictionary. Now we'll head on to the final data structure, which is actually a set. So a set, what distinguishes it from a dictionary is, you basically have only sequence of elements and then you don't have any key value pair. Also, another interesting point when it comes to a set is there are no duplicates allowed inside a set, right? So let's have a couple of examples with respect to set over here. So let me just create a set with the name S1 over here, and I'll put in these braces, and let me just put in some values. I'll type 1 and then I'll type ABC. Maybe I'll give 2, then I'll type gym 3. I'll just type Iron Man over here. So this is my set. Let me print out S1 over here. So these are all of the values which are present in a set. Now, let me go ahead and try to add duplicates and see what happens when I actually add a duplicate. So let me put in 1, 2 again inside this. So we see that we already have 1 and 2. I'm again placing the same elements. Now we get the same result because duplicates are not allowed. So when you add the same element again, it considers it to be one element. So duplicates are not counted. That was a number you might be thinking. Let me also do it with the character. So I'll type ABC again over here. I'll also type Jim, and then I'll also type Iron Man. Now I'll execute all of these individual cells. Again, we have the same result because no duplicates allowed. So guys, these are the basic data structures in Python, right? Now we are done with all of the basic Python concepts and we'll head to the data science part. So now before we head on and understand what exactly is data science, what I'll do is let's actually, I'll start with asking a very simple question again. So guys, could you tell me what is data? What comes to your mind when you hear the word data? So what do you think it is? Put down in the chat box, right? All of you who are attending the session. Now, simply put, data is just collection of facts, isn't it? If you think about it, right? So when you work with numbers such as 23, 8,000, 1 million, 10 million, or whatever, however huge that number is, that's just a fact. That's just data, isn't it? Again, when you say statements such as this is Sparta, I love pizza, my name is Jim, or whatever statement you make, that is again a fact, and that is again data. Now, it's not necessary that data should only be present in numerical or only string format. Now, because mostly of the advent of social media and technology, especially now in this decade or mostly in the last 10 years, we've got a lot of pictorial data and a lot of data which is present in the format of videos. So we've got all of this unstructured data which is present with us. So whatever you see on the social media, all of that is again data. Now, what is data science? So data science is basically taking up all of this data and understanding this data so that we can make up some or come up with some meaningful information which could help the business needs. So that would be the simple definition or the simple meaning of data science, because we have a lot of data. We have this extreme huge amount of data sources with us, and if we just sit on all of these data sources and if we do nothing, then we're actually being very stupid about this, aren't we? Because we're sitting on a gold mine, and it's very essential for us to actually mine that gold and make something out of that. Now, to understand this better, let's actually have a context on how the data was around 2 or 3 decades back, and how is the data now. So the data around 3 decades back was very small and structured. Now, when I say data was very small, the data was available in maybe kilobytes. And also, no one really thought of performing any sort of analytics on that data. Also, the data was very structured. So whatever data was there, it was present in proper right format. It was present in rows and columns. And since it was already there, no one really thought of performing any analytics on it. But now we've got this huge amount of data, and this huge amount of data is totally unstructured and is coming from multiple sources. So every single second there is millions and millions of data which is being uploaded on social media, isn't it? And now the question again is, what are we actually doing with this huge amount of data? So that is where data science comes in. If we actually use all of this data which is around us, which is in front of us, then it can solve our business needs. So there are, we can use all of this data to understand the customer sentiments. We can use this data to boost a company's revenue. And if we use data science techniques properly, we can even cure a disease, who knows. So right now, as we're taking this session, as you guys are attending the session, all of the AI professionals and data scientists are working with most of the microbiologists across the world to find a cure for the coronavirus. Now, isn't that amazing, right? So data science is everywhere, guys. Data is all around us, and understanding this data is the primary solution to most of our problems. So we've understood how the data was back then, how the data is now, and what exactly do we have to do with this data. Right. Let's look at some use cases of data science. Now, this is very popular use case of data science, which is used by most banks, which is fraudulent credit card transactions. Now, again, I'll give you an example for this. So now in this lockdown period, let's say you're just happily sitting at your home and watching some TV series on Netflix, and then you suddenly get a message from your bank stating that there has been a transaction of maybe $10,000, and you've actually bought a diamond necklace in Paris. Well, that sounds very strange, isn't it? We're actually sitting in Bangalore, India, and you've never bought even anything which is worth 10 rupees in the last 1 week, maybe, and suddenly there's a transaction of $10,000, and you bought a diamond necklace worth $10,000 in Paris. Now, you know that it's a fraudulent credit card transaction, but how does your bank know that it's fraudulent? How was it able to flag it off as a fraudulent credit card transaction, right? So this is where data science comes in. So all of your banks use different data science algorithms. You've used different data science tools to figure out, if these transactions are genuine or fraudulent. So what they do is they keep a record of your transactions and understand your purchase pattern or your transaction pattern. So let's say if you mostly buy things in the range of $1,000 to $2,000, and you don't exceed anything above that, and you've never been outside of India in your life, then your purchase pattern is limited to that, and the place of transaction is only limited to India, right? Now, since the data science algorithm is fed this data, your data science algorithm is fed all of the data about your previous transaction, and it learns from that data. And whenever it comes across new data, it checks whether this transaction is something which fits in your pattern or not. And if it finds it that there is something unusual with that particular transaction, it immediately fraudulent transaction, right? So that is where data science comes in. So isn't it truly amazing, right? So there's just one anomaly, and then your bank was easily able to find out that this was actually a fraudulent transaction. Now, not just banks, data science is actually used to tag whether a mail is spam or genuine. Now, I believe all of you would have a Gmail account, and all of you would have used Gmail at some point in your life. So, now most of your mails are categorized as spam. So, how does that happen? So again, data science working at the back end, my friends. So what is happening over here is, so let's say whenever a mail is sent, it would check up on the subject of the mail which is sent, subject, or basically the initial first two paragraphs of the mail which is sent, and it understands the context. So let's say if there are too many exclamation marks present in the subject, or maybe too many numbers. So what it does is it already has a preset dictionary where it has some fraudulent subject lines, which could be congrats, you won a lottery, or congrats, you won $1 million. And there could be a lot of exclamation marks, there could be a lot of special characters. So what your data science algorithm does in the background is it checks for all of these. So it checks whether there are a lot of special characters, exclamation marks, if the word jackpot has been used, if the word millionaire has been used, if the word maybe lucky has been used. And on the basis of this, it would flag it off as a spam mail. And not just this, there are also certain sources which are tagged as spam. Now, let's say if there is one particular site which sends you a lot of spam mails, and a lot of people tag that website as spam, then this algorithm recognizes that a lot of people have been tagging this as spam. So whenever the person from this website sends a mail, let me directly place it in the spam folder. Right. So all of this is automatically being taken care by your data science algorithm. So again, another interesting data science which you guys can look upon. Right. So we've looked at two useful use cases. So now let's head to the most interesting part, which is the data science life cycle. So these are the steps involved in a data science life cycle. So first is data acquisition, where you acquire the data, then you pre-process the data. So once you acquire and pre-process the data, you go ahead and apply the ML algorithms or the TS algorithms. Now, once you apply the algorithms, you'll have a result. Now, it's not necessary that the result which you get is actually correct. So that is when you would have to actually evaluate the result and find out if the result which you have is right or wrong. And once you evaluate and when you find that the result is actually correct, you will go ahead and represent your result in the form of beautiful graphs. So this is what is known as knowledge representation. And this is the entire data science life cycle, guys. So now what we'll do is we'll understand each of these steps in a much more comprehensive way. So let's start with data acquisition. So I've told you data comes from multiple sources and is present in multiple formats. So how do you actually choose your target data? So what you do is you need to have a data warehouse. You take all of this data, you dump it into the data warehouse. And so you have data in multiple formats. You would have a PDF file, Word doc, you would have an Excel file. So you'll take all of these and dump it into a data warehouse. Now, in that data warehouse, what you'll do is you'll make sure that most of the data, or like 90% of the data, is converted into one particular format. And when you have all of this data converted into one particular format, it becomes much more easier for you to do analysis. And from that data which is in a single format, you will choose only that particular domain which is of interest to you. Now, all of this data could be related to different domains, right? Now, it is not necessary that you go ahead and work with all of those domains. Now, this is also something which you'd have to learn as a data scientist. You'd have to differentiate between what is important and what is insignificant. Because if you start off with data which is totally trivial and insignificant to you, then you're wasting your time. So that is why it becomes essentially important for you to find the target data. Now, when you get the target data, what you do is you pre-process the data. You've acquired the data. This is when you'd have to pre-process the data. So now, once you have the target data, this data is not perfect. There are a lot of anomalies present in this data. So there could be a lot of missing values. There could be columns where the names of the columns are wrong. There could be missing rows, or maybe the values which are present are totally wrong. Right? So you'd have to make sure that this data is first put in a proper format. That is where data manipulation and data visualization come in. Let's understand data manipulation over here. So in data manipulation, basically, let's consider this with an example. So let's say your manager gives you a huge Excel sheet comprising of maybe 1,000 columns and 1 million rows. Now, out of these 1 million rows and 1,000 columns, you are asked to find out all those employees whose salary is greater than $100,000 and age is greater than 30, and your manager gives you only 5 minutes of time. Now, you'll think that your manager is actually evil, and he's being very rude to you, and his when you have to find the solution in just 5 minutes. But he's actually being right, and that is because you don't have to manually go through each of the record. I mean, if you're actually going through each of the 1 million records in the Excel sheet and checking the age of the employee and the salary of the employee, then you're actually being stupid. So this is where data manipulation comes in. Now, what you do is you apply these data manipulation techniques. And when it comes to programming languages, these are basically 1 or 2 lines of code. So what you do is you just put in these 2 lines of code, and that will easily give you the list of all of those employees whose age is greater than 30 and whose salary is greater than $100,000. Right? So that is how data manipulation comes in. Now, it's not just that. So you can also use data manipulation to find out missing values, to find out outliers, to maybe fill in wherever there are gaps. You can do all of that with data manipulation techniques. And then data visualization is also used for a similar purpose. Now, again, if you're given the same Excel sheet by your manager and you're asked to draw inferences from that Excel sheet. So by just looking at that Excel sheet, you will not understand anything because it's just a sheet which has huge amounts of data in it. And now, instead of that, if you actually present some bar plots, box plots, or scatter plots which are based on this data, now wouldn't that be very easy for everyone to understand what is actually present in that data, right? So this is where data visualization comes in. So in data visualization, what you do is you create different sort of plots so that you can draw inferences from the existing data. So these are the 2 important components of data pre-processing: manipulation and visualization. So we've acquired the data, we've pre-processed the data and understood and got some basic insights from the data. Now that is done, we can go ahead and fit our machine learning model. Now you have to remember that this machine learning model is built depending on your problem statement. You can't just go ahead and use any machine learning model on whatever data that you acquire. So you have to take in the factors of what data you're using, what type of data you're using, what is the type of result that you want. And considering all of these factors, you can go ahead and choose one particular machine learning model. So you'd have different machine learning models such as classification, regression, and clustering. So what is a machine learning algorithm? So we'll not go into the details of it. So simply put, it's just application of intelligent algorithms. And when you put in these intelligent algorithms on top of your raw data, that would give you meaningful information, right? So we've got the raw data. We've built some machine learning models on top of the raw data, and that has given us a result. Now it's time to actually verify whether the result given by the machine learning model is correct or not. So this is where pattern evaluation comes in. So what you do is, building just one model is not enough. You go ahead and you do trial and error. You build successive models. You build models of different types and understand which model works best on this particular data and which would give me the best result. So that is what is known as pattern evaluation. So once you're sure that you have your perfect model and this model will give you the perfect data, then you'll take that result and you'll show that result in the form of simple aesthetic graphs. So this is the final stage of data science lifecycle where you are showing your final result. Now, this is where the stakeholders come in. So now the stakeholders, you'd have to keep in mind that not all of the stakeholders would have the technical expertise. You as a data scientist would know the technical side of things, but then again, when you show them a technical result, they wouldn't really be able to understand it. So that is why when you show them the result in the form of dashboards, in the form of beautiful graphs, then it becomes very easy to interpret your findings. So that is where knowledge representation comes in. So these are the different stages involved in the data science life cycle. So guys, we've started off by understanding some basic concepts of Python. We've installed Python, we've looked at basics of Python, we'll work with basic data structures of Python. And then we've understood what exactly is data, what is data science life cycle, and then we've looked at the various components of data science life cycle. So now I'll go ahead to the Q&A session, and if you have any questions, you can drop in those questions. Now, also before I start off with the Q&A session, I'd like to inform you about Great Learning Academy. So we have recently launched Great Learning Academy, where we have more than 300 hours of free content available. So we've got 500,000 plus learners as of now, and we have 3 million plus monthly views. So as you see, we have all of these live classes scheduled where you can interact with faculty who are experts in their industries. So we've got popular courses with respect to data science, ML, artificial intelligence, cloud computing, and so on. And the best part is you can also earn a certificate when you complete the course. So not just this, it's not that you also get a certificate. There are also quizzes, there are assignments, there are projects, and also you have a community that you can depend on. So we've got this community of 500 plus thousand learners. You can interact with all of them, and if you're stuck anywhere, you can take your peers' help and understand where you're stuck. So guys, please do check out Great Learning Academy. The link would be shared in the description box below or the chat window by our team. So please do check it out. Right, so now I'll just go ahead to the Q&A session and I'll see what questions do I have for now. So Krishna asks, do I require OOPS concepts in learning data science? Well, yes. Now, as I told you, when it comes to object-oriented programming, we are mostly dealing with real-world entities. Whatever you're doing, you are dealing with real-world entities, aren't you? So let's say if you have to represent anything, so maybe you are creating a model on a new car and you want to test the fuel efficiency of this new car with pre-existing cars, then you need to have some baseline comparison. So object-oriented programming is very important. So I'd not see it as, if you don't know object-oriented programming, you can't learn data science. But if you want to be an expert at Python and at data science, then object-oriented programming becomes very important for you to learn. So guys, there are no shortcuts. You'd have to learn all the concepts in Python. You can't really just skip one part and go ahead to another part. So Ari Chandran asks, what is the difference between ordered collection and unordered collection? Okay, I'll explain this again, Ari. So ordered is where the data inside the list and the tuple is indexed. Unordered is where it is not indexed. So I'll show you the examples of it again. So I'll create a tuple over here and I'll add some values. I'll add 1, 2, 3, 4, and 5. Now, if I print this out, this is what I have, and what you see is each of them have an index. So tup1 0, right? I extract the first element. tup1 1, I extract the second element. Now I can do the same thing with a list as well. So I'll change this to be L1. I'll put in square braces over here. And so it seems like we have an error over here. What is the error? Okay, so I'll just create a new list instead of this. So I'll type in L1 and I'll type 1, 2, 3, 4, and 5. Right, so we've created L1, and similarly, if I want to extract individual elements on the basis of an index, I can do that. But when it comes to a set and a dictionary, they are unordered. You don't have indexes when it comes to a set and dictionary. So I'll create a set. Let me type, let's say 1, 2, 3, 4, and 5. Now, when I do S1, 0, let's see what you get. Now, every time you would actually get a different element, but okay, let me print S1. Okay, so I'm actually creating this wrong. I've created a tuple instead of a set over here. So let me type in 1, 2, 3, 4, 5. Let me put in S1 and let me try to extract 0. Right, so I get an error over here because set object is not subscriptable. This means basically we get this error because this is not ordered. Now, when I say this is not ordered, so all of these elements could be present at any index. So we don't really know, right? So that is why you can't extract elements on the basis of an index. Now, similarly, if I create a dictionary, let me put in orange over here. Let me put in 10. And then I'll type apple and then I'll give a value of 20. Now, if I type D1 of 0, let's see what do we get. Again, we get an error. Now, this we're getting because again, this is not ordered, right? So I hope that answered your question. Now, okay. So Vamsi Krishna asks, if I understand the session, can I jump to machine learning? So Vamsi, this was an introductory session to Python and the basic concepts of ML. So you'd need a bit more practice with respect to all of the Python concepts, and also you'd have to work with concepts such as NumPy, Pandas, and Matplotlib. So these are the primary libraries when it comes to ML. So especially NumPy and Pandas. So once you're good with NumPy and Pandas, that is when I'd suggest you to go ahead with the ML concepts. Yeah. So let me see, what else do we have? All right. So seems like these are the questions which we have as of now, right? So again, guys, another reminder. So we've launched this Great Learning Academy. So please do check this out. The description would be there in the chat box and also in the description box. You can check out the link over there. We've got courses with respect to different domains. You can earn a certificate, and you have different quizzes, assignments, and projects. And not just Great Learning Academy, please also do subscribe to our YouTube channel, as we'll be publishing more high quality content regularly in this time of lockdown. So yesterday we had also uploaded a JavaScript tutorial. If you guys have not checked it out, please do check it out. So it's a 9-hour tutorial. I believe if we have any programming enthusiasts over there, any web programming enthusiasts, you can check out the JavaScript tutorial. Right, guys? So this brings me to the end of the session. Thank you very much for attending it. And thank you, and be safe in this time of lockdown. Thank you very much.